Hello all, welcome back to my channel. I am Disha, pursuing BE in Electronics and Communication at Sri Venkateswara College of Engineering. I am here to give a presentation on Electronic Engine Control System. In this session, the topics to be discussed are: why electronic engine, what is electronic engine control system, engine functions and control, engine performance terms. Why electronic engine? Because electronic engine produces zero emission and gives higher energy efficiency and also reduces the operational cost as compared to the other engine. Next question is, what is electronic engine control system? An electronic engine control system is an assembly of electronic and electromechanical components that continuously varies the fuel and spark settings in order to satisfy government exhaust emission and fuel economy regulation. Block diagram given is generic electronic engine control system. This system receives its input signal from the various sensors in order to measure the state of the engine, and the received input signals are sent to the control unit. This control unit sends the output electronic signals to the actuator. This actuator in turn determines the fuel delivery and spark timing. This block diagram represents the engine functions and control. Engine control receives its input signal from the engine status sensor. The fuel metering is to set the air fuel mixture flowing into the engine through the intake manifold. And there is a spark control which determines when the air fuel mixture is ignited after it is compressed in the cylinder of the engine, and the power is delivered at the drive shaft, and the gases that results from the combustion is flown out by the exhaust emission or exhaust system. In exhaust system there is a valve to control. We are speaking about this valve. The amount of exhaust gas being recirculated here, it is recirculated back to the input, and a catalytic converter to further control emission. In addition, there is a subsystem that collects the evaporating fuel vapors in the fuel tank to prevent them from being vented to the atmosphere. These fuel vapors are later sent to the intake of the system from here. Intake of the system as a small component of the fuel being supplied to the engine. And the subsystem also includes EVAP here. At one stage of development, the electronic engine control consisted of separate subsystems for fuel control, spark control, and exhaust gas recirculation. The ignition system shows as a separate control system here. Although engine control is evolving towards an integrated digital system, as sensors are digital system, and these sensors include the temperature sensors also. The temperature sensor senses whether the engine is hot. If the engine is hot, Then it turns on the coolant agent. In this slide, we look on to the major controller inputs from engine. In the before slide, we saw the block diagram which consisted of total position sensor, that is TPS, mass airflow rate MAF, and engine temperature, coolant temperature CT. As I told, there were many sensors at engine status sensor, which also included the temperature sensor, engine speed RPM and angular position, exhaust gas recirculation EGR, valve position. We discussed about this also. And at the last, exhaust gas oxygen concentration. This actually determines the concentration of oxygen uh, present in the air and updates to the engine control. Major controller outputs from engine. Fuel metering control. This fuel metering control actually controls the fuel and air mixture entering to the cylinder for the ignition. And next comes ignition control. Ignition control actually controls whether there is the efficient air and fuel mixture or not. And in ignition timing, it determines the time taken to the ignition. And at the last, exhaust gas recirculation control from EGR valve. Here we discuss about engine performance terms. Power. Power is a measurement of an engine's ability to perform useful work. There is another power called brake power. Brake power, which is measured with an engine dynamometer. It is the actual power developed by engine minus losses due to internal friction. Another term is BSF. BSF is abbreviated as brake specific fuel consumption. It is a measurement of an engine's fuel economy. It is the ratio of fuel flow to the brake power output of the engine. RF represents fuel flow rate. PB represents brake power output. Torque. Torque is the twisting force of an engine's crankshaft by the cylinder pressure pushing on the piston during the power stroke. Volumetric efficiency. The variation in torque with RPM is strongly influenced by the volumetric efficiency or breathing efficiency. Thermal efficiency. It expresses the mechanical energy that is delivered to the vehicle relative to the energy content of the fuel. Calibration. Engine mapping. It is a process by which measurements are made of important engine variables while the engine is operated throughout its speed and load ranges. Thank you for watching the video, guys. Please do like, share and subscribe, and stay tuned for more electronic based interesting videos.